problem. 32 power 232 minus 17 power 232. There is a value that is given, that is 32 power 232 minus 17 power 232. Then n is divisible by. Yesterday we discussed a model based on a power n plus or minus b power n. Through this question, I wanted to discuss some concepts to you. First, write down the concept. First, write down the concepts which you know it. Then I will discuss a concept, probably something which might save a lot of time in little advanced level. Concept is a power n minus b power n. A power n minus b power n is always divisible by. A power n minus b power n is always divisible by. Is always divisible by a minus b and a plus b, as long as n is an even number, even natural number. A power n minus b power n is always divisible by a minus b and a plus b, as long as n is an even natural number. A square minus b square is a minus b into a plus b. 2 is an even number. So this example will show us that a square minus b square has got factors a minus b and a plus b. This question uses this concept. First we will discuss the generic concept, otherwise we will discuss the optimal concept even if you forget this one. So first thing, 32 power 232 minus 17 power 232. 232, it is an even number, so it is divisible by a minus b and it is divisible by a plus b. So 32 minus 17, it is 15. 32 plus 17, it is 49. It is divisible by 15 and 49. It is divisible by 15 and 49. So answer is 49 and 15. Answer is 49 and 15. I hope the idea it is clear. 49 and 15. This is one way to solve it. Yesterday I discussed, right, one important learning from this question. Yesterday I told you that composite number, any composite number, write down as a product of coprimes. Any composite number, please write down as a product of coprimes. There is an exception to this case. To only discuss that exception, we discussed this concept. Square of a prime number. If I take a square of a prime number, square of a prime number is nothing but a composite number, but it cannot be expressed as a product of coprimes. For example, 9. How can you write 9 as a product of coprimes? 1 into 9, 3 into 3. 3 and 3 are not coprime. HCF of 3 comma 3 is 3. Suppose 25, 1 into 25, 5 into 5. Suppose if I take 49, 1 into 49, 7 into 7. Are you all with me? So one important point please mention in your notebook. A composite number can be written as a product of coprimes except one kind of composite numbers, and that numbers are square of a prime number. A square of a prime number cannot be written as a product of coprimes. Divisibility rule of 12 is nothing but divisibility rule of 3 and 4. Divisibility rule of 15 is nothing but 3 and 5. What is the divisibility rule of 49? You cannot split it as a product of coprimes. That is exactly Euler's theorem will come into picture to help you out the divisibility rule of the square of a prime number by using a totient function, and helps us in finding where the remainder will be 1 or minus 1. I hope the idea is clear. Euler's totient function came into picture because the divisibility rule of a composite number can be written as a product of coprimes. But a square of a prime number, 3 square, 5 square, 3 square, how can you write it as a product of coprimes? 5 square, 7 square, 11 square, 13 square. These are nothing but 169 is 1 into 169 or root of 169 into root of 169. So this cannot be written. That is the reason little advanced level concepts of Carmichael-Quotient function, Euler's-Quotient function came into picture. Now I hope this idea it is clear. So if anybody asks you any composite number can be written as a product of coprimes, say that a square of a prime number may not be written as a product of coprimes. That learning should be there in your notebook. Second point. Second one. Suppose if this question is given to you, how will you solve this question? 32 power 232 minus 17 power 232. Now let us see. Suppose B 15 is there. Yesterday we discussed 15 is nothing but 5 into 3. 5 into 3. 49 it is there. Either you can 49 is 7 into 7. 49 is 7 into 7. Let us do first with 5. So these is nothing but remainder of 32 power 232 minus 17 power 232 divided by 5. 5 6 are 30. It is 2 power 232. 5 3s are 15. It is 2 power 232. Out. It is definitely divisible by 5. If it is divisible by 3, 3 tens are 30. It is again 2 power 232. 3 5s are 15. Again it is 2 power 232. Definitely divisible by 15. 15 anyway will come in the answer. None of these is not possible. 15 is there here. 15 is there here. Now that is the best method to check whether it is divisible. 32 power 232 minus 17 power 232 divided by 49. Idea is to tell you beyond 49. 49 ones are 49 minus 17. 17 power 232 minus 17 power 232 divided by 49. So directly it is divisible. So directly you can use the negative remainder concept in this question to get the answer fast. Negative remainder, both the cases you can use 49 as well as 15. 15 also will give you the answer very fast. 32 power 232 minus 17 power 232 divided by 15. 15 ones are 15. Positive remainder is 17. 17 power 232 minus 17 power 232. Negative remainder is giving you the answer fast. But if the number of terms are little more, right, probably determining in 2 terms it is coming very easily. 3 terms, 4 terms are there, then the logic might be little difficult. I hope the idea it is clear. Negative remainder is the best logic here, and a power n minus b power n, if n is an even number, is the best logic here. For certain complex problems, Euler theorem might be used. I hope the learning from this question is clear. Again I am repeating the learning. A composite number can be written as a product of coprimes except the square of a prime number. That is the learning from this question. Sir, what if the number of terms are little more? For example, if the question is, let me discuss another question. Remainder 1, 1 power 39, 2 power 39, 3 power 39, and so on up to 12 power 39 divided by 12 power 39 divided by 39. Divided by 39. 1 power 39, 2 power 39, 3 power 39, and so on up to 12 power 39 divided by 39. Please write down the concept. If k is an odd number, k is nothing but the powers. A1, A2, A3. If these values are in arithmetic progression, difference will be constant. Arithmetic progression, difference will be constant. If the difference is constant, a1 power k plus a2 power k plus a3 power k and so on, it is always divisible by sum of the bases, a1 plus a2 plus a3 and so on. Please make a note of it. If the power is an odd number, and the bases, the difference between the bases excluding the powers, if they are same, then the series is said to be in arithmetic progression. If k is an odd number, a1 power k plus a2 power k plus a3 power k, it is always divisible by sum of the bases, which is a1 plus a2 plus a3 and so on. For example, 1 power 3 plus 3 power 3 plus 5 power 3. Listen carefully. 135. 135 are in arithmetic progression. 3 is an odd number. Check it out whether it is divisible by sum of the bases. 1 plus 3 plus 5 is 9. 1 cube is 1. 3 cube is 27. 5 cube is 125. 125 plus 27, 152 plus 1, 153. 153, definitely it is divisible by 9. 9 into 17. I hope the idea it is clear. Please put a star mark on this concept. It is not the questions. I am not interested in discussing a particular question to you. If the nature of the question changes, how you should look at it from a different angles, that is what I wanted to teach you. If the k is an odd number, a1, a2, a3 are in arithmetic progression, then a1 power k, a2 power k and a3 power k. I hope the idea it is clear. I hope the idea it is clear. Now let us solve this second question. Let us solve this question. Once you attend all my workshop sessions, you will also be able to solve a lot of mock questions without using pen, and so on up to 12 power 39 divided by 39, 1, 2, 3 and so on up to 12. All that values are in arithmetic progression. Difference is same. 39 it is an odd number. 39 it is an odd number. So it is divisible by summation 12. Summation n is n into n plus 1 by 2. 2 6 are 6 13s are 78. 78 it is nothing but 2 into 39. 2 into 39. So any number divisible by 78 should definitely be divisible by 2 and 39. So answer for this question is 0. Answer for this question is 0. I hope the idea it is clear. 39. 39 can be written as 3 into 13. 3 into 13. In case if you are probably if you forgot this concept, what you can use is 3 and 13. 3 and 13, what you can use? You can use the negative remainder and you can also solve the question. That model also we will discuss. I hope the idea it is clear. One way to solve, the generic way to solve, and the another different way of looking at the question. 1 power 39, 2 power 39 and so on up to 12 power 39 divided by 39. 39 is nothing but 3 into 13. 3 into 13. 12 power 39 divided by 13. Remainder it is nothing but minus 1 power 13. 9. 1 power 39 minus 1 power 39. 11 power 39 divided by 13. It is minus 2 power 39. I hope the idea it is clear. So 1 power 39, 2 power 39 and so on up to 6 power 39. Remaining all will be minus 6 power 39 minus 5 power 39 minus 1 power 39. All of them will get cancelled. Similarly, you can also do it for 3. In case if you forgot the concept, as long as the denominator it is a composite number, write the number as a product of coprimes and do it individually. Do it individually. I hope the idea it is clear, right? 1 power 39, 2 power 39, 3 power 39. Similarly, you can do it for 3. 3 power 39, 6 power 39, 6 power 39, all these are out. 3 power 39, all are divisible by 3. And so on up to 12 power 39. All these are out. 1 power 39. 2 power 39 divided by 3. 3 ones are 3. Negative remainder minus 1. 1 power 39 minus 1 power 39 out. Next one, 4 power 39 plus 5 power 39. 4 divided by 3, 1 power 39. 5 divided by 3, minus 1 power 39. It is out. 3 power 39, 6 power 39, 9 power 39, 12 power 39 out. 4 terms are over. 1 power 39 plus 2 power 39 gets cancelled. 2 divided by 3. 4 power 39, 5 power 39 gets cancelled. 7 power 39, 8 power 39 gets cancelled. 10 power 39, 11 power 39 gets cancelled. Divisible by 3 and 13. 3 and 13. Therefore, the answer is 39. Depending upon your practice, you choose any method that is comfortable for you. As a teacher, I will tell you the why behind the question and what are all the various approaches that you can use to solve the question. Depending upon your practice and your comfort zone, you will take any method. Idea is to make you feel comfortable with a variety of the questions. I always believe in giving my kids quality questions more than the quantity questions. On a single question, I will do here and there all the twists. I will do it so that you will be able to understand the question with 100 feet down. I hope this question is clear. Those of you are listening to my class for the first time, again I am repeating, I am not interested in solving the PPT questions. I am interested in looking at the question and creating live questions on the spot, telling which question is best, which question is not best. I did Euler's quotient. Then I told you that Euler's quotient is not the best method. You can use the negative remainder logic. Like that, you should be able to complete it. I am a researcher. Next one. Oh, this is a very, very good question, sir. How many values of A are possible if x square plus ax plus 2400? This is nothing but a quadratic equation. If I equate it with 0, this got a quadratic equation. This has got some roots. Note, suppose if I got a quadratic equation px square plus qx plus r equivalent to 0. If alpha beta are the roots, sum of the roots is given by minus b by a minus q by p, and product of the roots is given by r by p. Here p value, it is nothing but 1. So sum of the roots is given by minus a by 1, and the product of the roots is given by c by a, which is 2400. Very, very good question, sir. Product of the roots is given by 2400. Now we have understood the question. Now, how many values of A are possible? How many values are possible such that this equation has integral roots? That means case number 1, it is nothing but an integer values. Okay, this is case number 1. Second one, natural number values. Alpha, beta are natural number values. Now, what is the question that he is asking? He is asking the question for a value. He is not asking how many values alpha and beta will take. Now listen carefully, sir. For example, if alpha is 2, beta is 3. If alpha is 3, beta is 2. What is alpha plus beta? If alpha is 2, beta is 3. 2 plus 3 is 5. A value will be minus 5. If alpha is 3, beta is 2, what is a value? Minus 5. If 1 is 2, another is 3, or if 1 is 3, another is 2, the value of a is not changing. That means if I am taking 2, 3, I should not take 3, 2, because both of them will result in the same value for a. I hope you are all there with me. 2, 3 and 3, 2 cannot be taken. Reverse cannot be taken. If the reverse cannot be taken, what is that I need to find out? Here there is a confusion whether I should use ordered pair or an unordered pair. Ordered pair is the way in which the values are written. But alpha 2, beta 3, alpha 3, beta 2, in both the cases I will get the same value for a. The first important learning from this question, because I need the value of a, what I will do is first write down this point. This question is asking for an unordered pair. This question is asking for an unordered pair. This question is asking for an unordered pair. That is the first thing. Why? Because sum of the roots is given by minus b by a and the product of the roots is given by 2400. Case number 1. Case number 1. Alpha and beta. Which values it is taking? Integral values it is taking. Which values it is taking? Integral values it is taking. Now listen carefully. Please write down this point. Number of ways of writing a number. Number of ways of writing a number as a product of. Number of ways of writing a number as a product of two integers. Two integers. In which case we are doing unordered pair. Why ordered pair we are not taking? Why? Because the reverse case will give me the same value for a. Same value for a. First let us do one example. 12 is there. 12 can be written as 1 into 12, 2 into 6, 3 into 4. Reverse cannot be written, but negative into negative it is positive. Minus 1 into minus 12, minus 2 into minus 6, minus 3 into minus 4. I hope the idea it is clear, right? Reverse cannot be taken. A comma b is equivalent to b comma a here, because reverse case I will get the same value. Just 1 minute, sir. Right, now 12 is nothing but 2 square into 3 power 1. Totally how many factors are there for this number? 3 into 2, which is 6 factors. How many cases I got? 1, 2, 3, 4, 5, 6. So the first question, it is nothing but the equivalent to number of factors. Please write down. It is equivalent to number of factors. Please remember, we are doing in unordered pair. In unordered pair, number of ways of writing a number as a product of two integers, it is equivalent to number of factors. Unordered pair means a comma b is equivalent to b comma a. That means the product of the factors, whatever the value that is there in the right hand side, what you are expected to do? You are expected to find the number of factors for 2400 and write the question as it is. Ideally it is a number of factors by 2 if it is a natural number, because it is an integer. Positive into positive it is positive, negative into negative it is also positive. Very good question. A lot of students might do a calculation mistake. Alpha beta it is nothing but 2400. These are nothing but integers. These are nothing but integers. So 2400 it is nothing but 24 into 100. 24 it is nothing but 2 cube into 3 power 1 into 100 is 2 square into 5 square. So it is nothing but 2 power 5 into 3 power 1 into 5 square. So what will be the answer for case number 1? If it is an integral roots. If it is an integral roots, answer is nothing but number of factors. Answer is nothing but number of factors. So it is nothing but 2 power 5 means 0 to 5 6 cases, 0 to 1 2 cases, 0 to 2 3 cases. 6 2s are 12, 12 3s are 36. First one answer is 36. How beautifully number of ways of writing a number as a product of two factors, that concept can be used to find the value. I hope it is clear. Suppose for example 2400, it is 1 into 2400. Alpha is 1, beta is 2400. Alpha plus beta is minus a. If I substitute 1 doublet, I will get one value. 2 into 1200, I will get another value. I hope it is clear, right? Minus 1 into minus 2400, I will get another value. Every doublet will give a unique value for a. Every doublet will give a unique value. Integral roots. I hope there is no confusion between integral roots and natural number roots. Natural numbers are nothing but the numbers which can be counted and which is to the right hand side of 0, 1 to countable infinite. Integral values includes negative numbers, 0 and positive numbers. Negative numbers, 0 and positive numbers are integral values. Natural number values are the numbers which are only positive. I hope the idea it is clear. Second question. What is the second question? Alpha plus beta equivalent to minus a. Alpha beta equivalent to 2400. Second case is alpha and beta are taking natural number roots, are taking natural number values. Now write down, because we are doing unordered pair. Next case. What is the next case? In an unordered pair, number of ways of writing a number. Very, very good problem, sir. Number of ways of writing a number as a product of two natural numbers only. Previous case it is two integers. Now it is two natural numbers. First we will take an example, then we will deduce the conclusion. 12 is 1 into 12, 2 into 6, 3 into 4. There is no negative case. Natural numbers cannot take negative numbers. 12 is nothing but 2 square into 3 power 1. So 3 into 2, 6 by 2. So if it is natural numbers, I will get a case number of factors divided by 2. Number of factors divided by 2. So 2400, which I got it as 2 power 5 into 3 power 1 into 5 square. 32 into 3, 96. 96 into 25 is 2400. What will be the answer? 36 divided by 2, 18. 36 divided by 2. 1 into 12, 2 into 6, 3 into 4. If I take a simple natural number 12, I got 3 cases, which is number of factors divided by 2. In the question it is 2400. 2400 number of factors are 36 by 2. Now why I took only an unordered pair? Again I am explaining. 12, if I take 1 into 12 and 12 into 1. Now tell me, if I take an ordered pair, alpha plus beta equivalent to minus a. 1 plus 12 is 13, a is minus 13. 12 plus 1 is 13, a is minus 13. The value of a is getting duplicated. The question is, how many distinct values of a are possible? How many unique values of a are possible? Duplicates should be eliminated. Very, very good question. This question discusses the concept of in how many ways can you write a number as a product of two factors. The fact